Part 2 of chapter 5, section 4. Where's your paper at?
I'm doing it in my room.
Get it out.
I don't have a paper.
Solving radical equations. Let's get into it.
That's actually cool, man.
So today, we're talking about identifying extraneous solutions. So squaring each side of an equation can sometimes introduce solutions that are not solutions of the original equation. These solutions are called extraneous solutions. So for example, if I have like the square root of x equals negative 2, how would I get x by itself? How would I get rid of that square root?
You gotta square them both.
Square both sides, right? If I square that, that'll cancel out the square root.
What's that?
Whatever I do to one side, I got to do to the other. So what would I be left with on the left-hand side? Okay, so squaring both sides, what would I be left with on the left-hand side? X. What's negative 2 squared? Negative 2 times negative 2? 4. So that looks like it should be my solution, right? So let's plug back into the original problem. The square root of x equals negative 2. Plugging in 4 for x. What's the square root of 4?
Oh my gosh.
2. Does 2 equal negative 2? No. So that'd be an extraneous solution. This actually has no solution. So that's why we check our solutions, because today we're going to be seeing some extraneous solutions that are not actual solutions for us. Okay? Yes?
So can't you just tell by like if that doesn't have a negative and the one on the right does? Wouldn't that just always be?
What do you mean?
Like how it is now. See how like
Right here?
Yeah. How there's only one on that side?
Yeah?
Wouldn't that just be that on every single one? And extraneous. Right?
What do you mean on every single one?
So say you just remove the 2 and put like a 6.
Okay.
Is that still extraneous?
Yep.
So then
Because I can't take the square root of anything to get a negative, can I?
So yeah, then if it's a negative on just one side, then it's,
Now, what if I give you like...
I don't know. I was guessing. Well, no, because it's cubed. So it would be negative.
So I could have a negative, right? I could take the cube root of a negative number and get a negative number, right? So I could possibly have a solution there. Okay? But the point is, sometimes my solutions are called extraneous, so they're not actual solutions. Does that make sense? That's why we check our solutions to see if they're actual solutions or not. Okay? So, solve x equals the square root of x plus 6. Yesterday, what was my first thing I needed to make sure happened before I squared both sides?
You get the x on the other side. The x squared.
What?
X by itself.
Before I get x by itself, what do I have to get by itself?
The thing.
The what?
The whole thing.
The radical, right? I got to make sure the radical is by itself on one side of the equation. Is that the case here? Yeah, the radical doesn't have anything multiplied by it, divided by it, added to it, or subtracted from it, does it? So, since it is by itself, what can I go ahead and do?
Start.
Square it to get rid of the radical. Whatever I do to one side, I got to do to the other. So I get x squared equals what's left on the right-hand side?
Plus 6. Oh, x plus 6.
X plus 6, right? I'm solving this equation. Do we remember how to solve a quadratic that looks like this?
I don't know. I subtracted the x.
Subtract x, I agree with that. Can I combine x squared and negative x? No. So I just leave it as x squared minus x
Oh, what?
equals 6. Where would I go from there?
I don't know.
Don't you?
Any other ideas here?
Whoa. No.
You guys remember factoring?
Yeah.
No.
What else do I need to bring over? Well, what's left on the right-hand side?
Nathan said
6.
6, right? How would I bring that 6 over?
Minus it.
Subtract 6. So x squared minus x minus 6, because the 6 can't combine with anything, can it? Equals, then I'd be left with 0 on the right-hand side. This is kind of ringing some bells. Hopefully a little bit. Solving quadratic equations. What can I do with that left-hand side now? The x squared minus x minus 6. What's the word that starts with an F that I used earlier? Factor, right? Let's try to factor this. Create our two sets of parentheses. What's our variable we're dealing with? X. If I have a minus sign in front of my C value, are my signs going to be the same or different? Different. So one's a plus, one's a minus. And now I can do my T-chart. What goes in this upper left-hand corner? -6. What goes in the upper right-hand corner? What? -1. So I'm looking for two numbers to multiply to give me -6, to add to give me -1. Someone give me two numbers that multiply to give me -6. -3 and 2. What's -3 plus 2? -1. Are those the two numbers I want? Yeah, they are. Good guess. So I get x plus what? 2. X minus 3. And there's my quadratic factored. Factored form of my quadratic. Everyone okay with that? How do I solve this now that it's in factored form? Yeah, set each factor equal to 0. So set what equal to 0? X plus 2. And what? And x minus 3. And now I can solve each of these two little equations. Subtract 2 from both sides. X equals what? -2. And then I add 3 to both sides. X equals 3. So it looks like -2 and 3 are my solutions, correct? What do I need to do, though, just to make sure that they are solutions? Plug them in to check them. Can I erase this left-hand side of the board?
Sure.
Give myself room to check. So I'm plugging into this original equation. Let's start with -2. Anytime I see an x in my original equation, I replace it with -2. So, what's -2 plus 6? 4. What's the square root of 4? 2. Does -2 equal 2? No. So x equals -2 is what?
An extenuous.
An extraneous solution, right? So x equals -2 I cannot include as a solution of my equation. So that one's not a solution. Does that automatically mean that 3 is a solution? No, I still have to check it. So let's plug 3 in now. So anytime I see an x, I replace it with 3. And I do want to see this work on your paper when you're doing your assignment. I want to see you plug it in on your paper and work down both sides. What's 3 plus 6? 9. Square root of 9? 3. Does 3 equal 3?
Yeah.
Yes, it does. So what's my one and only solution here?
3.
X equals 3. Very good. Questions on example 5? Does that make sense for us?
So that's the answer?
Yep, just x equals 3. X equals -2 is an extraneous solution, so it's not an actual solution for us. Sometimes you could have no solution. If neither one of them worked, I'd have no solution. Okay? We good? Next one. Solve 13 plus the square root of 5n equals 3. Is my square root, my radical, completely by itself on one side of the equation? No. So I got to get rid of some things to get it by itself, right? Before I can start solving for the variable. What's my first step to get the radical by itself?
Subtract 13.
Very good. Subtract 13 from both sides. Left with the square root of 5n on the left. And what's 3 minus 13? -10. We okay with that? Is the radical now by itself?
Yeah.
Yeah, it is. So how can I get rid of the net radical now that it's by itself? Square that as well as the other side. What's negative 10 squared? Negative 10 times negative 10. 100.
Oh my.
And how do I get n by itself? Divide both sides by 5. N equals? What? 20. And so it's looking like n equals 20 is my one and only solution. But can I bank on the fact that it is?
Well, this
No,
is
you gotta
solution,
check it.
So that's correct.
Huh?
That's correct.
Say what?
That is
But did you
correct.
plug it in?
Well, I gotta check it. Remember, we gotta check it. Plug it back in for your variable. And work down both sides of the equation. What's 5 times 20? 100. What's the square root of 100? 10. And 13 plus 10? 23. Does 23 equal 3? No. So n equals 20 is what?
False.
An extraneous solution, right? So n equals 20 is not an actual solution. So do I have a solution here? No. No solution here. Questions on example 6?
That's so weird.
It is weird, isn't it? I'm sorry.
So I mean, yes.
So yeah, this is why we check our answers. Because sometimes they come out to be extraneous solutions. I just got to trash them. Okay? We good with that?
Yep.
Can I move on to the last example?
Yep.
Word problem.
Nope.
The period p in seconds of a pendulum is given by the function p equals 2 pi times the square root of L over 32, where L is the pendulum length in feet. A pendulum has a period of 4 seconds. Is this pendulum twice as long as a pendulum with a period of 2 seconds? Explain your reasoning.
Yeah, it takes longer.
Well, 4 seconds is twice as long as 2 seconds, right? But it's asking if the pendulum is twice as long as a pendulum with a period of 2 seconds. So I can't just go off that fact, can I? What am I going to have to do here?
It is longer.
It doesn't say, is it longer? It says, is it twice as long? Right? So what do I need to do here?
I mean, this is kind of weird.
You gotta do
Because it is twice as long if it's 2 and 4.
Well, that's the period of it.
I know.
It's asking about the pendulum length, though.
Oh.
Right? Any ideas what I need to do here?
I say you just
Plug it in.
Plug what in where?
4 into P.
There you go. We can plug 4 into P, because P stands for the period, right?
Yep.
And it tells me that a pendulum has a period of 4 seconds. So let's see how long that pendulum length is that has a period of 4 seconds. So 4 equals 2 pi times the square root of L over 32. We okay with that? Now I'm solving for L, so I can get the pendulum length that has a period of 4 seconds. Is the square root by itself on one side of the equation?
no.
No. What's with it?
2 pi.
2 pi. How do I get rid of 2 pi if 2 pi is being multiplied by it?
5 by 2 pi.
Divide both sides by 2 pi. Four over 2 pi would reduce down to what? Not 2 pi.
1 pi.
2 over pi. The 4 and 2 would simplify to 2 over 1. Or just 2 over pi, right? Equals square root of L over 32. Is the square root now by itself? Yeah, it is. So how do I get rid of the square root?
Square.
Square both sides, right? So I've got 2 over pi squared. Let's go back to our exponent rules that we learned before spring break. If I've got two things being divided by each other, raised to a power, how do I handle that? What exponent does 2 have right now? Inside the parentheses. 1. What about pi? 1. Remember, every exponent in the parentheses gets multiplied by that exponent outside the parentheses. So what's 2 times 1? 2. So I'd get 2 squared over, what's 2 times 1? Over pi squared.
Well, yeah.
Equals L over 32, not 33. Golly, I'm rewriting the whole thing. And what's 2 squared? 4. So let's just erase that and put 4. And is L by itself now? No, how would I get L by itself? Multiply by 32 on both sides. So L equals, what would 32 times 4 give me?
128.
So 128 over pi squared, which if I type that in a calculator,
9 point. Why'd you put that? About?
yeah, that means approximately. I'm going to round here because I'm going to get a decimal. So 128 over, use our pi button here, squared. It's approximately 12.97 feet. I just typed that in the calculator. Everyone okay with that?
Could we use any unit of measurement?
No. It says where L is the pendulum
in
length
feet.
in feet.
I didn't see that.
Yep. So, I found the pendulum length of a pendulum that has a period of 4 seconds, right? What's the question asking me again?
Is it longer than the other?
Is it twice as long as a pendulum with a period of 2 seconds? How do you think I'm going to tell if it's twice as long or not?
Plug it in.
Plug what in where?
Do the 2 seconds where the P is.
Yep. I'm going to replace the P with 2 seconds and get that pendulum length. Then I compare the 2 lengths of the pendulums. So I got to do this whole problem again just with 2. Yay. Yay. So plug in 2 for P this time.
No baseball.
And now, once again, I'm solving for L. I got to get the pendulum length of the pendulum that has a period of 2 seconds. So what's our first step? Our steps are going to reflect what we did on the other problem as well. So what's my first step? Is the radical by itself? There we go. Divide by 2 pi. 2 over 2 pi reduces to what? 1 over pi. The 2's are both reduced down to 1, right? Okay, square root's by itself. How do I get rid of the square root? Square both sides. Let's go up here and give ourselves a little more room. So what would 1's exponent be inside the parentheses? 1 to the first power, right? So what's 2 times 1?
2.
What's 1 squared? 1. Very good. What's pi's exponent in the parentheses? 1. What's 2 times 1?
2.
So I get 1 over pi squared equals L over 32. And now, how would I get L by itself? Multiply by 32 on both sides. What's 32 times 1? 32 over pi squared, which is approximately 3.24 feet. So there's the pendulum length of a pendulum with a period of 2 seconds. So is the pendulum that has a period of 4 seconds twice as long as a pendulum with a period of 2 seconds?
No.
Is 12.97 two times as long as 3.24? No. It's probably about 4 times longer. Yeah, about 4 times longer instead of 2 times longer.
Dang.
And there we go, we found our answer. I'd say, no, it is not twice as long as a pendulum with a period of 2 seconds. It is about 4 times longer. Any questions on example 7? Everyone see how we approached it, though? How we got to our answer. Can I move on? Here we go. Page 269, numbers 45 through 63 off. Are there any questions that were pertaining to my recording before I end my recording?